let's gather around, take your seats, and let's continue talking about NGINX Unit and how that system can launch and run your applications. It's a very interesting title slide I prepared for you. This is literally the only slide for this talk. And I want to introduce, first I want to introduce the engineering team of NGINX Unit. And the whole engineering team is here at the conference. It's Igor, Valentin, Maxim, and I just talk about this. All right. Basically, what we are going to be doing is looking at how NGINX Unit works in our environment. I will guide you through I will guide you through the configuration of Unit, through the compilation process, through modifying and changing your Go applications to run through the NGINX Unit. And also, I'll show you how to run multiple versions of the application and multiple versions of application language here. All right. I already downloaded the source code. You can do that using GitHub, Mercurial repository, or using just the simple tarball link from our website. First, let's clean it up. All right. And what we have here is our configure script. Usually, when I launch a configure script, first thing I do is launch in the help and see what we can configure in the source code. The most important parts here will be the configuration options for each of our languages. Before going into the language configuration, first thing I'm going to do is configure NGINX Unit itself. The prerequisites for that are quite easy. You just need the C tools, and for the languages themselves, you will need the libraries, the development kits for PHP, Python, and languages. And for Go language, you just need the Go package. All right. Now we have it configured, and now let's start configuring our languages. We got PHP here, and we see that it's been configured for PHP version 7.0. That is really good. And now let's configure it for Python. OK, so for Python, it found version 2.7, which is installed in the system. But I do know that I installed not only Python 2, but also Python 3 in this same environment. Let's see what I have here. Let me press Tab here. I see Python 2, Python 3, and so on. Let me take a look on how configure Python will show me the options of what I can configure. You see, we need the Python config that we can provide directly. And the Python config for the version 3 here will be this one, Python 3.5-config, which means I can configure this with the configuration file, like this one. And now we see that we have a unit module prepared for us for Python 3.5. It does not delete the previous one. It just adds another module. Now we have configured the sources for PHP version 7, for Python 2.7, and Python 3.5. OK. In addition to that, we need to do that for the Go language as well. Let's first take a look at the parameters. We will build it with the default Go package, which comes with the system, which is Go 1.6. And if you want to use newer versions, you can specify the parameters here. All right, let's go let's configure Go, and that works just well. So the first thing I want to build here, well, let's do make all and compile NGINX Unit with the configuration that we just defined. This is not a very long process. It just takes less than a minute to compile it. And let's see what we have here. Now, in our build directory, we see a unit daemon which is a binary right here. And we got the objects, the modules, compiled in that same directory. And as I said, we got one for Python for the default version, for the version 3.5, and the PHP module. All of those modules will be discovered automatically when a unit runs. All right, let's do that. Let's run unit. But before running it, let me see what other options can we do. And we can specify for unit to be non-daemonized, which is important if you want to run it in a container. You can give it the PID log files directory where you put the modules, usernames, and so on. Another important parameter that I want to use today will be the control socket. Since we talked that unit is fully API controlled and it doesn't require a configuration file, the thing we want to use, we want to actually connect to a unit the ways how our infrastructure likes it. OK, by default, there's going to be a socket file in a file system. Let's open an HTTP let's open a TCP port and let's make the API available via HTTP on port, let's say 8443. So we're going to use the control parameter. And I will put the IP address in here because I don't want it to listen on the API on every available public address of the system. All right. So we just started the unit daemon with this API control socket. OK. In the process list on the bottom of the screen, you can easily see that unit launched launched the main process. And directly in the process line, you see where you will be able to connect for controlling and modifying its configuration. It's going to be this IP and port right here. Unit immediately creates the controller and router processes. You all went to the keynote a few minutes ago, and we discussed at length how controller and router processes work together in the unit. OK. Well, the first thing we're going to do is let's see what this API gives us. All right. It just gave us a JSON object with listeners and applications which are not defined at this point of time. It launched empty with a very fresh and clean configuration, and it doesn't listen on any ports and hasn't launched any application at this moment. All right. I prepared a file here with the configuration. And this file has a very simple listener and very simple one application defined. The application is just PHP info, and that PHP info file is available right here. Let's see the file itself. I wasn't making any modifications to the PHP file. I wasn't making any modifications to the PHP packages themselves. Just took them the way they are and launching it with the unit. All right. Well, let's upload this file using the put method directly into this API control port. We'll do curl put request. We need to specify the file and our API port. All right. The first thing that we see is the response from unit that reconfiguration was performed. All right. Let's see what was performed. Let's curl the configuration again. Let's see what's in there. And yes, we can see all of that information that we just put into that API directly available. OK, so we defined the application. We defined the workers and everything. But we are not seeing any application processes here. Let's take a look at how our application works. And let's open a new tab for that. And we have it on port 8300. Here we go. Here's our PHP info. And we see that our server API is unit right here. OK, in the process list, you immediately can see that we don't only have the controller and router process, but also this new application process. The number of those application workers, the maximum number is what we defined in our JSON file in our configuration that we uploaded. OK, that was pretty easy, right? Let's look at another application that we prepared here. And that application is a Python app. OK, so this JSON file, it doesn't have a name of the application. It defines a Python application with a version 3 of Python language, a couple of workers, and also you can see that it lists a different user and different group parameters here. OK, let me show you the application itself. The application is really easy. All it does here, it's just showing us the very simple the system version. OK, let's have this demo, this Python application. That file, let's put this file into our API right here. OK, it's port 8443. Now, where do we put this file without the full definition of the configuration? We need to put it into the applications. And let's give it a name. All right, we just defined it as a Python_sample. And this application is now right there. Let's see what we have in our list of applications right now. We have our port 8300 listener. We got the application PHP info. We got the Python sample. Our PHP info application worker, it's still there. The PHP info page is working perfectly. But now we define some new entity right here. OK, so what we can do right now for this application, we can either create a different listener and have it listening on a different port, or we can redefine this existing listener, which is port 8300, and see this application the way it works in this environment dynamically without changing the listener. OK, let's have a show of hands. Who wants that application to run on a new port? OK, and who wants to redefine the existing port for this new application? OK, we're redefining the existing port to see the new to see how the new application works. For that, we're gonna do this. We're gonna access this object, the listener's 8300, and we're gonna access this parameter application and change its value from PHP info to Python_sample. OK, let's do that. That's going to be some tricky command here. It's going to be a put request. The data of the put request will be a string, which is Python_sample. And the URL where we will put that will be our listener's URL with the ID of the listener. And then the parameter will be application. All right, we just got that one in here. All right, we see reconfiguration is done. Let's take a look what we have here. And yes, our application was redefined for this same listener. What's interesting in the process list is that nothing changed here. We haven't removed the PHP application. It's just not bound to any listeners at this point. And now the thing that we're going to do, we're going to refresh the page. And here we go. We can see that the Python app is running. And we can see that Python worker process has been created right here. OK, at this point, you can see the Python app and PHP app running at the same time in that same system. And both of them are running under different users, the PHP user and Python user in this Linux system. And we can dynamically manage and dynamically change whatever we want about this listener and application. There are interesting use cases for that. Let's say you want to update your application with a new version. Just put the code in a different directory and change the root using this API. Or change the listener into a completely new instance of application. Or create a new application object in this API, test it out with a separate listener, just put some minor amounts of traffic into that new version of the application. Once it's ready, just swap the listeners using one API call. All of the changes are graceful. The connections are not broken. Connections are not reset. And the listening sockets are still open at any point of time if you're changing it. So this is fully, truly dynamic. All right, let's see what else we have here. I prepared a longer file. And in this file, what we see right here is a bunch of different listeners. We got a PHP application, an application defined in Python version 2, in Python version 3, and also a very interesting one, which is the Go Hello World application. OK, now the Go applications are really interesting to build. Let's go directly into this directory. And let's see what we have here as our hello.go app. What we did, we created the Go package, which is called Unit. And we need to add Unit as the package right here in the code of our application. Now, instead of using HTTP listen and serve, I will use unit.listen and serve right here with the same parameters. Now, how that will work? If the application is launched directly, it will fall back to the HTTP functionality of Go, and it will listen on the port. It will be available right now. It will be available the way you usually launch the Go applications. However, if unit will launch the application, if unit will take that binary and start it, the application will not open an HTTP port. Instead of that, it will be communicating with unit router using the shared memory that Igor explained in the keynote. And that system will provide you a consistent HTTP stack across your applications, regardless of the language and the platform that you are using for these applications. All right, we already have this Hello application compiled. It's a very simple app. We have more complicated applications running in the demo booth, where you can see apps like Grafana running with NGINX Unit and some other apps as well. All right. We have it right there, and we had the full JSON file that I'm going to upload. The full JSON file that I'm going to upload through the API, and it will be able to launch 4 different applications: PHP, 2 versions of Python, and Go. All right, let's do that. I will use the put method. I will specify the file. Curl command requires the symbol before specifying the file. And let's put that in our 127.0.0.1 and the port that we chose right here. All right, we got the configuration going. Since I renamed the applications, our Python sample application was removed, and the workers of the Python sample applications are not there. However, our PHP application in the full JSON file was exactly the same PHP application that we started from. Since that wasn't a change, Unit didn't kill any PHP processes. It kept them live. It kept them accessible on that same port, because that wasn't a change. Only the Python applications and Go applications were changed in this environment. All right, let's see all of those applications, how they're working. So port 8300, that's going to be our PHP application. Here we go. That's PHP 7.0 PHP info. Let's go to the next port, which was 8400. 8400 was the Python application defined as a Python 2.7 version. And I had almost exactly the copy of that at the next port, 8401, which is exactly the same application running in a different version of Python. You see now that once we started launching those applications, we see the processes coming in, and we got the Py2env, Py3env application. Now let's open the last one of those, which is the Go app. And this is a completely different application right here. We can see it in the process list directly. All right. Now what happens if we want to delete some of those apps? Well, it's very easy. You can use the same API for cleaning things up. We can use the delete method, and we'll apply that delete method directly to the application. And which application do you want to delete right here? PHP. OK. Yep. What do you think will happen right now? It's invalid. We cannot delete it right now because we have a listener socket bound right now to this same application. Let's clean up the listening socket first. All right, so our PHP application was listening on the socket. That was 8300, this one. All right. What happened here is quite interesting as well. We deleted the socket. Now our port 8300 will not be accessible. Here we go. The site can't be reached. The port is not there. However, in the list of processes below, you can still see the PHP application. We only deleted the listener. We only deleted that part that was changed. And we were not touching the rest of the system that is still supposed to be live. Maybe you want to run that same PHP application on a different port. You just create another different listener, bind it to that same application, and you're live without changes and without restarts even of a single app. All right. Now let's try to delete our PHP application. And here we go. PHP application is out of here. All right, so this is a really fun system right here. And you can create, delete, update parts of the application, parts of configuration using any of those requests that I've shown you. Really easy to use and really configurable. All of those things are available on any modern Linux system and with all of the modern versions of PHP, Python, and Go languages. So here's the thing. We started to get a lot of comments and a lot of questions on social media and even on GitHub and everywhere else. So for this session, we wanted to leave more time for your questions, and we want to answer all of those questions right here. So we have the whole engineering team as Igor, Valentin, and Maxim right here, and myself for answering the questions. All right, let's ask the questions. Here we go.
So let's assume that I take traffic in NGINX and then currently forward it back to something like PHP FPM with FastAGI. How, in this case of using
So yes, the question was about having the variables passed from NGINX into unit, similar to the PHP, FPM, similar to FastCGI params, right? All right. Let's have the engineering team up here, and let's help answer this question. I must say that many of your questions will be answered with the words, yes, we have this planned. All right. Can we have a portable microphone here? All right, we'll get the microphone right now because we're getting a lot of questions. Let's have a microphone here for that. Mm-hmm. Oh, this one is working. Mm-hmm.
So it should be configurable, of course, and we will provide a way how to pass additional variables using HTTP headers from NGINX to unit, of course. And for now, it populates environment variables according to HTTP request. So if you want to pass, for example, IP address from the client connection to NGINX, you have to use custom HTTP header. But eventually, I think that you will be able to put NGINX unit to the external environment, and don't have NGINX behind unit. And in this case, there will be no problem at all to populate all the environment variables.
Mm-hmm. Yes, go ahead.
Just to clarify, each worker is a standalone process, not a thread. Is that right?
Yes, that's right. And as you can see, they use different user and group, and they're isolated. And if one process dies, so only the request that is served by this process will be failed. Everything else will be processed as is. And what I should mention that a unit router process, it's multi-threaded, but each thread is asynchronous like NGINX worker process. So you have as many threads as you have cores in your system, and each thread can handle thousands of connections like NGINX worker process.
Okay, and a follow-up, how do you monitor the health of the workers? And under what circumstances would you shut them down?
So the question was how we monitor the health of the workers and how they shut down, at what conditions, and how we can control that. This is one of the things that we are planning in a very short-term roadmap right now, as having the pre-fork module, pre-fork model for creating the workers, and monitoring them using the pretty much standard system-level tools as for memory, timeouts, and so on. This is planned. This is a short-term roadmap. Mm-hmm. Yes?
What happens to the existing configuration when, for example, the NGINX dies?
Sorry, I didn't quite understand the question.
What happens to the existing configuration that we made?
Mm-hmm.
The main process dies.
OK, so what happens to the existing configuration?
Okay,
Mm-hmm.
For now, it will just disappear. But we are going to add persistence in the short term. I think it will be ready in a week or so. So if the main router process or master process will die, you can restart unit, and it will start with the previous working configuration.
Yes, as of right now, what you can do is when you are making changes to your configuration, it is completely dynamic. The changes might come from different sources for different reasons, but it gives you a fully consistent view on what the configuration is. You can simply dump that configuration JSON into a file, and that will be your last known working config. Of course, the persistence features are very important, and we will have them done very quickly.
persistent configuration just only done. It's not intended to manual editing. So you should avoid it. Of course, you can edit it, but you shouldn't do it because all your editing will be lost after the next remote.
So we expect users to interact with NGINX Unit only using this API. So we don't expect them to edit our persistent storage. Of course, you can because it will be simple JSON, but you shouldn't do that.
All right. Yes.
So I wonder how the management authorization works. So who can send this API, send request to this API?
Yep. Got it. The question was about securing the API access. What I did in this demo, I enabled API access only on localhost on 127.0.0.1 and only on one specific port. By default, it launches the API in a Unix domain socket, which is only accessible locally in the system. Now, here's what you can do in addition to that. If you go to our website into integration with NGINX article, right here, we actually defined how you can secure your API using NGINX tools. We already know how to deliver secure websites and secure APIs in the world. And what you can do here, you can install NGINX, configure access lists, configure proxying into the control socket directly. You can configure client certificate authentication. You can have basic authentication and all of the NGINX security tools right in front of the unit naturally as you would have in front of any APIs.
Yeah, for now we recommend to use Unix domain sockets with root credentials, but eventually we are going to add TLS support and client certificates authorization and various other methods of authorization to be able to control the privileges and who can manipulate with this API interface.
All right. All right, we got another question here. Sorry, I couldn't hear this. CH-root environments. Are we planning this, the CH-root environments?
Yes, we plan to support root environments and probably we will even support C groups to more isolated processes from each other.
And also virtual inf for Python applications, of course.